Okay, this is tops question 31 till 38. Okay, this is the rest of them over here. So let's start. A geometric progression has a third term of 63, okay, and a sum to infinity, which is 4 times the first term. Always with these questions, if you want my opinion, always write down your given, because that's the easiest way to solve, okay? So G3 is equal to 63, and the sum to infinity is 4 times the first term. So the sum to infinity is equal to 4 times the first term, 4G1. Okay, find the first term. So what do we know about the sum to infinity? We know that the sum to infinity is equal to G1 over 1 minus R. So we know G1 over 1 minus R is equal to 4G1. So I think we can solve this equation, right? We can swap, you can cancel out G1. How can you cancel out G1? You guys know if you have a denominator, you can swap it with the other side, right? So you're going to get G1 over 4G1 is equal to 1 minus R. And now you can cancel G1, you're going to get 1 minus R is equal to 1 over 4. Solve this equation, you're going to get R is equal to 3 over 4. I think you guys know how to solve this, right? Anyway, so we now have R equals 3 over 4. Can we find the first term? Yes. What do we know? We have the third term. What do we know about the third term? The third term is equal to G1 times R to the power of 3 minus 1, right? So to find G1, it's simply G3 over R to the power of 3 minus 1, which is just R squared. So G3 over 3 over 4 squared. Let's do it on our calculator just so you can see. So 63 over 0.75 square. You're going to get 112. Let's see, is that correct? 112. Type. An arithmetic progression is such that, zoom in a bit so you can see, such that the 13th term is twice the 8th term. So this one, it took me a bit of time to solve, but now that I understand, it's very easy. So the 13th term, so A13, is twice the 8th term. Okay, show that the sum of the first 11 terms. They want to see that S11 is equal to 11 times the sum of the first 6 terms. So we need to prove this. طب, what do we know? We know this. Okay, what can this tell you? طيب, the first thing I did was actually I tried to use this. Okay, but it didn't work with me. So I tried to use a different rule, which is that what is A13, what is A8? A13, you guys know the nth term, an, for any arithmetic progression is a1 plus n minus 1d, right? So a13 will just be equal to a1 plus 13 minus 1, which is 12d, okay? Equals to a8. What's a8? Same rule, a1 plus 7d. Why 7? Because n minus 1d, okay? So I think we can solve this equation. You're going to get that over here. 2 times a1, let's distribute a1 plus 12d. Distribute the 2, it's going to be 2a1 plus 14d. You can take the a1 here and the 14d there. You're going to get a1 is equal to negative 2d. So you kind of solve this equation. Can you use this for later? We don't know. Let's see. What's S11? What's S6? S11 is equal to n over 2 a1 plus an, right? Like, that's the formula. So we're going to do 11 over 2 a1 plus a11. Walid, why aren't you using 2a1 plus n minus 1d? I guess you can use it, but it's the same thing. Okay, we're going to see that it's the same thing here. If you want, you can use 2a1 plus n minus 1d. Yeah, let's use 2a1 plus n minus 1d, because aslan, you don't have S11, you don't have a11 or a6. So yeah, we're going to use, it's better to use n over 2, 2a1 plus n minus 1d. When do we use this? When we don't have the nth term. Type. Also, if you didn't use this, if you use the first one, you're going to have to substitute a11 with n minus a1 plus n minus 1d. Anyway, so n over 2, so it's going to be 11 over 2, 2a1. What's a1? Negative 2d plus n minus 1d. What are we talking about? a11, right? So 11 minus 1, which is 10d. So we're going to get that the sum is equal to 11 over 2, negative 4d plus 10d. So we're going to get 6d inside, right? 11 over 2 outside. Cancel 6, you're going to get 33d. So S11 is 33d. How about S6? We're going to follow the same rule. S6 is equal to n over 2a1 plus n minus 1d, this formula, right? So 6 over 2, 2a1. What do we know about a1? It's negative 2d, right? Plus n minus 1d. So 6 minus 1d. Close the brackets. 6 over 2 is 3. Negative 2 times 2, negative 4d plus 5d. We're going to get negative 4 from 1d. 3 times 1 is 3d. So you get S6 is 3d. Let's see now. Let's apply. 3d, they're asking us to prove that's 11 times. 3d times 11. Is it equal to 33d? Let's see. 3 times 11, 33d. So you proved it. Question 32. A bank loaned out $3,000. The loan is repaid by weekly payments. Okay. which are an arithmetic progression. So it's not geometric, it's arithmetic. Okay, the first payment is $30 and the debt is fully repaid after 12 weeks. Find the 10th payment. So you can think of this as a sum. Why sum? Because we're adding and we're fully repaying the 3,000. So the sum is actually equal to 3,000. How many terms do we have? 12 weeks. So S12 is equal to 3,000. And what's also S12 equal to? N over 2. Let's see. Do we have the 12th term? No. So I'm going to use this formula. 2a1 plus n minus 1d. Okay, let's do it. So n over 2, 12 over 2. 2 times 30 because a1 is 30 plus n minus 1d. So 12 minus 1 times d. What do we know this is equal to? 3,000. So let's simplify. 6, 60, 11d, right? Is equal to 3,000. Divide by 6, divide by 6. You're going to get 60 plus 11d is equal to 500. Subtract by 60, you're going to get 11d is equal to 440. So you're going to get d is equal to 440 divided by 11 is obviously 40. Now that you know d is 40, can we find the 10th payment? Of course we can. So a10 is equal to a1 plus n minus 1d. n minus 1d, right? طيب. So a1 we know is 30. So 30 plus n minus 1, so 10 minus 1 d. Perfect. So 30 plus 9d. We know d is 40. So 30 plus 9 times 40. So 30 plus 360 equal to 390. Very easy. Okay. Over here, 390. I'm going a bit fast because you can slow me down. Play me on 0.5 speed if you want. But it's 2 p.m. and I need to have this video out. Find the sum to infinity of the geometric progression whose first term is 18 and whose second term is 12. This is very easy. So S infinity is equal to G1 over 1 minus R. We have the first term and second term. How do we find the ratio? Ratio is just equal to G2 over G1, right? If you have this 2 consecutive terms in a geometric progression, you can just divide the second term by the first term. 12 over 18 is equal to, I think, divide by 3. You get 4 over 6, 2 over 3. You should get 12 over 2 over 3, right? Yeah. So 2 over 3. So the sum to infinity would be G1, which is 18 over 1 minus 2 over 3. So it's going to be 18 over, you can do whatever you want. You're going to get 54. Is that correct? 54. Very easy. Question 33. By the way, please, if you're solving any question in your written part, make sure to write down your formula, okay? Please. Find the sum of all the integers between 100 and 125 that are divisible by 6. So obviously, between 100 and 125, it's a very small bound. So personally, what I would do, I'd start at 102, 108, 100, and whatever, keep on going, and just add them up. But since we're doing it in the arithmetic progression way, if you get in the exam, what if they gave you between 1000 and 2000, you know? Obviously, the numbers that are divisible by 6, if you start with a number n, the next number to be divisible by 6 would be n plus 6, right? Because you know what I mean? So let's say, 30 is divisible by 6. What's the next number that's divisible by 6 after 30? 36. You know, can you think of any other number divisible by 6? Divisible, by the way, means divided. Like, you can divide by it and not get a remainder. Then after 36 would come 42. You realize how every time it's divisible, you add 6, right? So likewise, if they told you divisible by 4, you do plus 4 plus 4 plus 4. So as you can see here, it's kind of an arithmetic progression, with the difference being, in this case, 6, if it's divisible by 6. Type, okay, what do we know? What do we know? We're going between 100 and 125. So what's the closest number? What's the first number after 100 that's divisible by 6? Obviously, 100 isn't divisible by 6. I'm pretty sure you guys know. Okay, so let's try 101. 101 is obviously not visible. Let's try 102. Okay, 102 is divisible. So we're gonna think of it like an arithmetic progression of numbers divisible by 6. The first number would be 102, and we're gonna keep on adding by 6. Since it's a very small bound, you can do it manually, but to do it in a proper way in the arithmetic progression, you need to know how to do it. Okay, so we know a1. We're gonna consider a1 as 102. Type. We're going until 125. So the number an should satisfy, you guys know any a1 is equal to any an is equal to a1 plus n minus 1d. What do we know? What do we know about our sequence? We know a1 is 102 and we know d is equal to 6, right? So a1 is 102 plus n minus 1. We don't know what n is. N minus 1 times 6. And what is our region? What is our bounds? We need to know, because now we're looking for the sum. How many numbers? Sum of how many numbers? Man, this is why I'm trying to find n. Okay, this is why I'm trying to find n. So we know that our n, our an, it has to be less than what? Less than 125. Why less than 125? Because we're going between 100 and 125. Okay, so if you solve this, you're gonna get, let's do it. You're gonna get 102, distribute the 6, plus 6n minus 6, less than 125. 102 minus 6 is 96, plus 6n is less than 125. Subtract, you're gonna get 6n is less than, I think, 29. Okay, so you're gonna get n is less than 29 over 6. As a decimal, 29 over 6 is 4.83. So can n be a decimal? Of course not. N is only positive integers, 1, 2, 3, 4, 5, 6. So obviously, since n has to be less than 4.83, what's the maximum n value I'm gonna get? Obviously 4. So I'm gonna have 4 terms in this arithmetic progression of numbers divisible by 6. So now can I find the sum? Yes, I can. So Sn is equal to n over 2, 2a1 plus n minus 1d. Why am I using this? Because I don't have the 4th term. So n over 2, so 4 over 2, 2 times, we know our first term is 102, plus 3, because 4 minus 1, times d, which is 6. So you're going to get 2 times 202 plus 18, and you're going to get 440. 444, 2 times 204. Yeah, I forgot to add this. Yeah, 444. So just to recap what I did, whenever you get a question like this, always figure out what your constant difference is. Okay, it's always going to be arithmetic. Your constant difference is always the one you're being divisible by. That's the first thing. Figure out what your a1 is. Okay, because you're looking for the sum. To do the sum, you have to do this formula. So to do this formula, you can't do it without knowing the n, the a1, and the d. So you can find each one you can find each one step by step. You can find d by knowing what's divisible by. You can find a1 by just seeing what's the closest number bit in my bounds. What's the first number in my bounds that's actually divisible by 6. Try it on your calculator. And then find n by doing what I did here, knowing that any an has to be less than the maximum value. Okay, like I did here. Part B, the first 3 terms of a geometric progression are 16, y, and 9, respectively. Where y is positive, find the value of y. Okay, this is very easy. You have g1 is 16, g2 is y, and g3 is 9. طب نحن what do we know? Whenever you have 2 consecutive terms, you know r is equal to g2 over g1. And what do we know r is also equal to? G3 over g2, right? So we know that these two, g2 over g1 and g3 over g2, are going to be equal because they're both equal to r. So y over 16, whenever you have 3 consecutive terms, the second one over the first term is equal to the third term over the second. That's how it works. G3 over g2, so 9 over y. Cross, you're going to get y squared is equal to 16 times 9, which is, I don't know, 16 times 9, I think 144. Yeah, 144. And you're going to get y is equal to square root 144, which is 12. Why didn't I consider y as negative 12? Because they said y is positive. Okay. Find the sum to infinity. Obviously, sum to infinity is going to be equal to g1 over 1 minus r. How do I find r? You can do g2 over g1 or g3 over g2. It doesn't matter. Now that we know y, it's very easy. I'll just do g2 over g1. So 12, because y is g2, which we found is 12, over g1, which is 16. So it's going to be 3 over 4 as your ratio. So the sum to infinity g1 over 1 minus r is 16 over 1 minus 0.75, because 3 over 4 is 0.75. You can put 3 over 4 in your calculator. Some people, they see me, they copy exactly what I do, and I say, why? No, do whatever you're comfortable with. You're gonna get 64. That's correct. Question 34. The first term of an arithmetic progression is a, and the common difference is d, where d does not equal 0. Write down expressions in terms of a and d for the first 3 terms. For the first 3 terms, the 11th term, and the 17th term. Okay, let's do it. So we know the first term is a and the common difference is d. So write down expressions in terms of a and d for the first 3 terms. So this is very easy, obviously, part a. For the first 3 terms, so they want us just to write what is a1 equal to. a1 is equal to a1 plus n minus 1 d. Obviously, since they said the first term is a, so just substitute. a1 is equal to a plus 1 minus 1 is 0, so this gets counted. So a1 is equal to a. How about a2? Following the same rule, a1 is a plus n minus 1, so 2 minus 1 d, so you're going to get a plus d. So they're saying write it in terms of a and d, so your answers are supposed to look like this, okay? They're supposed to look like this. a3, using the same rule, a1 we know is a plus n minus 1d, so 3 minus 1, which is 2d. So that's a3. For the 11th term, we said it's a11 is equal to a1, so a plus n minus 1, so 11 minus 1, which is 10d. Very easy. And then for the 17th term, it's going to be a17 is equal to a1, so a plus 17 minus 1, 16d. These questions, part A is very easy. Now they know. Now they're saying, sorry, the first term, the 11th term, and the 17th term are the first three terms of a geometric progression. Show that a, so the first term, is equal to negative 25d. So we have a geometric progression g1. It's equal to the first term of our progression, which is a. They're saying g2 is the 11th term, which is a plus 10d. And they're saying g3 is our 17th term, which is a plus 16d. Show that a is equal to negative 25d. Always, I tell you, when you have three consecutive terms in a geometric progression, use what we did in the previous question. g2 over g1 is equal to g3 over g2. Right? Because g2 over g1 is equal to r, the ratio. And also you can find r by doing g3 over g2. So since they're both equal to r, that's it. Perfect. So a plus 10d is equal over a is equal to g3, which is a plus 16d over a plus 10d. Cross multiply, you're going to get 8 plus 10d squared, which is just a squared. I'm not going to show you how to expand. Khalas, you know how to expand. A squared plus 2 times a plus 10 times 10d, which is 20 ad plus 10d squared, which is 100d squared, is equal to a squared plus 16 ad. Type. We can cancel a squared on both sides. Why? Because if you move it there, a squared minus a squared just cancels. Type. Over here, we can factor d out on both sides. So we're going to factor d out and get 20a plus 100d is equal to 16d. ad, sorry. d with d. You're going to be left with 20a plus 100d is equal to 16a. Take 16a here, you're going to get 4a is equal to, take the 100d there, it's going to become negative 100d. You're going to get, divide by 4 on both sides, you're going to get a is equal to negative 25d as asking in the question. Find the common ratio of the geometric progression. This is exactly like the question we did earlier. They first told us to use we first used the three consecutive terms and equated them, and then they asked us in the part after that was to find the ratio. And now that we know this, can we find the ratio? Obviously we can. To find the ratio, we can either do g2 over g1 or g3 over g2. I'll just do g2 over g1 because it's easier. I have less terms to work with. So a plus 10d, r is equal to g2 over g1, so a plus 10d over a. What do we know a is equal to? Negative 25d. So we're going to do, substitute a with negative 25d, so it's going to be negative 25d plus 10d over negative 25d. This is going to be negative 15d, right? Negative 15d over negative 25d. Cancel d with d. Minus with minus. 15 over 25 is going to be 3 over 5. So that's going to be equal to my r. Let's see. Part C, 3 over 5. It needs a bit of work, but you need to be a bit patient. So this is what they did for part B. A plus 10d equals radical. Huh? Oh yeah, I guess that works. Okay, but that's too much work, صراحة. Anyway, the way I did, I think, is better. 35, a progression has second term of 32 and the fourth term of 18. So they're saying find the first term in each of the following cases if it's arithmetic and geometric. So they're saying that a progression a2 is equal to 32 and a4 is equal to 18. Find the first term if the progression is arithmetic. So we know a2 is equal to a1 plus n minus 1d, so 2 minus 1d, which is just d. And we know a4 is equal to a1 plus n minus 1d, so 4 minus 1d, so 3d. So a1 plus d, so 32, a1 plus d, sorry, a1 plus d is equal to 32, and a1 plus 3d is equal to 18. We have a system of equations that you can easily solve. If you want, you can subtract the first one by the second one. You can take d to the other side. You can get a1 is equal to 32 minus d and substitute over here to find a1. You can substitute a1 with 32 minus d here, so 32 minus d plus 3d is equal to 18. Minus d plus 3d is 2d, so 32 plus 2d is equal to 18. So you're going to get 2d is equal to 18 minus 32, I don't know, what is it, 14 maybe? Negative 14. 2d is equal to negative 14. So d is equal to negative 7. You can use this method. This works. Also, I was thinking you can use, you have a4 and a2, you can use a4 minus a2 is equal to 4 minus 2d, right? An minus am equals n minus md. You can use this and you can do 18, therefore you can do 18 minus 32, which is negative 14, equals 2d, and you're going to get d is equal to negative 7. And then you can just substitute d is equal to negative 7 into this or into this to find a4, a2. Anyway, they're asking us to find the first term, huh? We're not done. We found d, but they're asking us to find a1. So we know a1 is 32 minus d. We're just solving a system of equations. This is grade 7, so they know how to do this, huh? a1 is equal to 32 minus d, so 32 minus 7, so 39. Let's take a look. Is it 39 in the case of being arithmetic? Yes. Yeah, yeah, they did what I did. شايفين؟ طيب, how about when the progression is geometric? G2 is equal to 32 and G4 is equal to 18. طيب. Can I find the ratio having G2 and G4? Yes, we know the ratio of any Gn over Gm is equal to r to the power of n minus m, right? طيب. G4 over G2, that means would be equal to r to the power of 4 minus 2, which is just r squared. So 18 over 32 is equal to r squared, knowing that the ratio is positive, so we're going to do square root and get the positive answer only. So square root 18 over 32. I think it stays 18 over 32. It's 3 over 4. Divide by, yeah, you can divide up and down the square root. Yeah, you can divide by 2 up and down. You're going to get 9 over 16 and then square root. Yeah. Okay. Anyway, ignore that. R is equal to 3 over 4. Again, they want us to find the first term. We know that G2 is actually equal to G1 times r to the power of n minus 1, which is just 1, so r. Or you could use G4 is equal to G1 times r to the power of n minus 1, so r cubed. Whatever you want, but this looks easier to me. So I'm going to use that G2, 32, is equal to G1, which is, we don't know, we're trying to find it, times r, which is 3 over 4. So how do I find G1? I divide by 3 over 4 on both sides. So I can get 32 divided by 3 over 4. And I'm going to get 42.6. Let's take a look. What's the answer? 128 over 3. Okay, yes, perfect. If you get a fraction in your exam, say 128 over 3 or 40, how much was it? 42.67. Okay, but with sequences, you have to write the fraction. Okay, because 42.67 isn't exact. You need an exact answer for sequences. For that reason, you use a fraction. Okay, question 36. We only have 2 left. They look pretty simple, inshallah. The fifth term of an arithmetic progression is 36, and the sum of the first 5 terms is 150. Find the first term in the common difference. So they told us that a5 is equal to 36, and we know that the sum of the first 5 terms is 5 over 2. The sum of the first 5 terms is 150. How do we find the first term in the common difference? Okay, what is the sum of the first 5 terms? The sum of the first 5 terms is equal to n over 2, a1 plus an, or 2a1 plus n minus d. But since I have a5, I can just use this one. Okay, it's easier. So 150 is equal to 5 over 2. a1, we're trying to find it, plus a5, which is what? 36. Can we solve this? Of course we can. You can divide by, you can just solve this. You know, everybody has their own way of solving. I'll do this. Now a1 plus 36 subtracted by 36, you're going to get a1 is equal to 24. But what do we need, Kaman? We need the common difference. Okay, you can use that a5. You can use this. a5 is equal to a1 plus n minus 1d, so 5 minus 1, which is 4d. You can use this fact and say that 36 is equal to 24 plus 4d. You're going to get that d is equal to 3 when you solve this. So a1 24, d is equal to 3. Let's take a look. a1 24, d is equal to 3. Type. The first term of geometric progression is 750. So g1 is equal to 750. And the fourth term is negative 6. Find the sum to infinity. We know that the sum to infinity is g1 over 1 minus r. And my PC is starting to lag from how much I'm recording. I need to clear it out. But anyway, g1 over 1 minus r. Okay, can we find, we have g1, we don't have r, but we have g4 and g1. So what do we know? Gn, using Gn over Gm is equal to r to the power of n minus m, you can find the ratio, right? So G4 over G1 is equal to r to the power of 4 minus 1, which is r cubed. So negative 6 over 750 is equal to r cubed. So r is just going to be equal to the cube root of negative 6 over 750. So cube root of negative 6 over 750. And you're going to get negative 1 over 5. So r is equal to negative 1 over 5. Type, okay, r is negative 1 over 5. Hella, to find the sum to infinity, I can just do sum to infinity is equal to G1, which is 750, over 1 minus r, which is minus 1 over 5. Okay, please pay attention to the double minus. Okay, don't get this wrong. It's such a stupid mistake to make that will cost you your whole written part. Okay, 1 plus 1 over 5. 625. So let's see, the sum to infinity is 625. Yes, perfect. Question 37. The fourth term of the arithmetic progression is 184. So A4 is equal to 184. And the sum of the first 10 terms is 1600. So S10 is equal to 1600. What's S10? Is it the open board program lagging? I think it's the open board program. Okay. Yeah, it's definitely open board. I don't know if you guys can see it in the recording. Anyway, so S10 is 1600. Find the 12th term. Type, what's S10? We know S10 is equal to using the rule n over 2, 2a1 plus n minus 1 d. So why are you using 2a1 plus n minus d? Because I don't have a10. Okay, that's why. But you can tell, well, you don't have a1 either. So, okay, a1 is easily find it. It's easily, you can find it easily. Type, okay, let's start doing some stuff here. What we know a4, right? What's a4? A4 is equal to a1 plus n minus 1d, right? And what's n in this case? 4 minus 1d. So we know a1 plus 4 minus 1d is equal to 184. So we're going to get a1 plus 3d is equal to 184. طيب, can I find an expression for a1 here? Yes, I can. a1 is equal to 184 minus 3d. So can't I substitute here a1 with 184 minus 3d? Of course I can. So let's continue with this over here. We know that the sum of the 10 terms 1600 equals n over 2, 10 terms, so 10 over 2, 2a1, which is 184 minus 3d, plus n minus 1d, so 10 minus 1, 9d. Let's start solving. 2 times 1, I'm not going to cancel because you can't cancel the 9 as well. I would cancel only if I can cancel both terms, and I wouldn't want to work with fractions. So 2 times 184 is 368, so 368, 2 times minus 3 is minus 6d, plus 9d, close. Okay, and you have 5 outside because 10 over 2 equals 1600. Let's see. Minus 6d plus 9d, 3d. صح؟ طيب 368 plus 3d وعندك ال 5 outside equals 1600. You can divide by 5 on both sides. So 1600 divided by 5 my sound is being okay. 320. So 368 plus 3d is equal to 320. Okay. Can you find d? Of course you can. You can take 368 to the other side. So 320 minus 368. Now divided by 3, you're going to get d is equal to negative 16. What are they asking? The 12th term. Okay. The 12th term. I don't even have the first term. And I'm doing all this just so I can find the first term, which is 184 minus 3d. So a1 now, I can find what a1 is. 184 minus 3 times negative 16. So you're going to get 184 plus 48. Just do this on your calculator. You're going to get 232. Knowing now a1 is 232 and d is equal to negative 16, can I find the 12th term? Of course I can. a12 is equal to a1 plus n minus 1d, so 12 minus 1d, so 11d. So I can therefore say 232 plus 11 times negative 16. Let's do this on our calculator. 232 plus 11 times negative 16. I'm gonna, what's that? 56. Is that correct? Is it 56? Where am I? 56. Okay. So see, they found d first and a1, and then they did a12 is equal to a1 plus n minus 1d. Type. Part B. A geometric progression has a first term of 1. So g1 is equal to 1. And a common ratio of r. Okay. A second geometric progression, let's just say r equals r, has first term 4. So we can call the first term here 4. And common ratio 1 over 3r. So r2 is equal to 1 over 3r. The two progression have the same sum to infinity. Find the values of r and s. So they want us to find the sum to infinity and the value of r. Type, what's the sum to infinity? It's g1 over 1 minus r. We know that they're both equal for both progressions. g1 here is 1, r here is just r. We know it's equal to the g1 over 1 minus r for this one, because both sum to infinities, it's given that they're both equal. So g1 here in this case would be 4 over 1 minus r in this case is 1 over 3r. We know that these are equal. Okay, I'm gonna simplify this. 1 minus 1 over 3r is just gonna be multiplied by r up and down. Sorry, multiply by 3 up and down. You're gonna get 1 minus 1 over 3r. Multiply by 3 up and down, you're gonna get 3 over 3 minus 1 over 3r. You're gonna get 2 over 3r. Why am I doing this? It's just a bit neater. I don't want a mess. Okay, so you're gonna get 2 over 3r over here. Okay, you know, I'm gonna keep it as 1 minus 1 over 3r, and then I'm gonna write under it. Okay, so 1 over 1 minus r is equal to 4 over 2 over 3r. What I did here is, it's completely your choice. So I like doing it because it makes my work a bit neater. Okay, طيب, let's cross multiply. 4 times 1 minus r is going to be 4 minus 4r is equal to 2 over 3r. Can we find r? Very easy. Take 4r to the other side. You're going to get 4 is equal to 2 over 3 plus 4 is going to be 14 over 3r. R is going to be equal to 12 divided by 14. Just solve this. 4 times 3 divided by 14, or you can divide whatever you want. You're going to r is equal to 12 over 14. You're going to get 6 over 7. So r is equal to 6 over 7. Now, can I find the sum to infinity? Of course I can, right? They want us to find r and the sum to infinity. So let's use this one. This one looks easier to work with. So 1 over 1 minus 6 over 7. So you're going to get 1 over 1 divided by 7. Should be 7. Yeah, so sum to infinity command will be 7. Type, let's see here. What's the answer? Oh, that ain't what I got. Hold up, what did I do now? 1 minus r over 3. Yeah, I know I'm stupid. Wallah, this is what happens when you try and be a smart ass. Uqsam billah. 1 minus 1 over 3r. I don't know how I got 2 over 3r. Wallah, I don't know. So this is what happens. Don't be a smart ass, guys. Okay, just solve normally. 1 minus 1 over 3r, 1 minus 1 over 3r. Anyways. So 4 minus 4r equals to 1 minus 1 over 3r. Let me fix my working. Use a bigger eraser. You're gonna get, okay, 1 minus 1 over 3r. You can take 1 there minus 4r here. You're gonna get 3 is equal to 4 minus 1 over 3r. So you're gonna get 11 over 3r. So you're gonna get r is equal to 9 over 11. Yeah, and then now the sum to infinity, let me go back to the other tab. The sum to infinity would be 1 over 1 minus r. So 1 over 1 minus 9 over 11, and you're gonna get 1 divided by, okay, you're gonna get 11 over 2, so 5.5. So it's equal to 11 over 2. Since it's an exact decimal, you can put 5.5, I think. Or you can keep it as a fraction, عادي. Okay, for our last question, one part, nice and easy. In an arithmetic progression, the sum Sn of the first n terms is given by 12n minus 3n squared. Find the first term and the common difference of the progression. Okay, I guess we don't really have much to work with other than this. So they told us Sn is equal to 12n minus 3n squared. And what do we know Sn is equal to? N over 2, 2a1 plus n minus 1 d. Yeah, so I guess we're going to work with this. So we're going to distribute this n over 2 inside. So we're going to get, you know what? No, I don't want to distribute. Sn is equal to this, and they told us Sn is equal to 12n minus 3n squared. You can just solve this equation. You can distribute the n over 2, but I hate working with fractions because I'm going to get n minus 1d over 2, which is disgusting. Okay, so I'm going to multiply by 2 on both sides. So I'm going to get n 2a1 plus n minus 1d is equal to 24n minus 6n squared. And I think now it's very straightforward to distribute. So you're going to get 2a1n plus, oh, let me expand this. Hold up, let me continue expanding what's inside. Okay, so you can get n 2a1 plus dn minus d equals 24n minus 6n squared. Let's continue. You now distribute the n inside. You can get 2 a1n plus dn squared minus dn is equal to 24n minus 6n squared. Okay, if I'm looking at this and I'm saying, okay, what the fuck am I doing? I just realized أنا أهبل. Okay, I'm sorry. I looked at the solution. I'm like, oh, that's way easier than what I'm doing. So they told us the sum for any n number, for any number n, the sum is equal to 12n minus 3n squared. So when for a1, n equals 1, right? So if you just substitute, n equals 1, you're gonna get 12 times 1 minus 3 times 1 squared. You're gonna get 12 minus 3, which is 9. So that means a1 is equal to 9. Then the sum of the first two terms, you want s2, it's equal to, so like for the sum, okay, let me repeat this. So for the sum of the first one term, n equals 1, right? So if you just substitute n equals 1, you're going to get the sum of the first one terms is 9. And obviously, if this, the sum of the first one term is 9, that means the first term is 9. Yeah, it's common sense. So the sum of the first two terms, that means n equals 2, and you substitute n equals 2 over here. So you're going to get 12 times 2 minus 3 times 2 squared. You get 24 minus 12, you're going to get 12. So a2 is equal to 12. So they're only asking for the first term and the common difference. But to find the common difference, I can find a2 and then subtract a2 by a1. So now a2 minus a1, so 12 minus 9 is equal to 3. So d is equal to 3. Very, very easy. Okay, I don't know why I... Whoa! a2 minus a1, s2 is equal to 12. Oh my god. I found s2 to be 12. Right? You get 12 here. But what's this 12? It's not a2. It's the sum of the first two terms, not a2. Right? So don't make that mistake. So s2 is equal to 12. What's s2? It's a1 plus a2. Right? So a1 plus a2 is equal to 12. So a1, which is 9, plus a2 is equal to 12. So you're going to get a2 is actually 3. Okay? So now to find the common difference, when I subtract a2 by a1, I'm going to do a2 minus a1. So it's going to be 3 minus 9, which is equal to negative 6. That's it. Okay? Thank you so much for watching. Good luck. Sorry for a long recording.